Welcome back. In this video, we're going to be talking about a specific reaction type again, and this is a double replacement reaction. It's also called a double displacement reaction. Evan, Paxton, this one's for you guys. I love your comments. If you think it's good, give me a thumbs up and appreciate your feedback. Okay, so we're talking about double replacement reactions. It's a double replacement reaction. What happens in this type of reaction is you have a compound, an ionic compound, Ad plus Bc. And the letters they just represent cations and anions. And these two, when they react, you end up with Bd plus Ac. And the cations and the anions have traded partners. So the A right here ends up swapping with B, and B ends up partnering up with D. So that is what has happened here. Please remember this right here, these are the reactants. These are the products. So you've got an ionic compound here and an ionic compound here. Ionic meaning there's a metal and a non-metal, metal and a non-metal. If you happen to be one of my students, red card, blue card, red card, blue card. That's what's going on here. Now these types of reactions, so double replacement reactions, usually occur in aqueous environment. The reactions occur in water, aqueous, if I can spell that, environment. The law of conservation of mass applies. The left-hand side has got to equal both in terms of the number of atoms and the mass, the right-hand side. So the reactants must equal the products in terms of mass. They don't have to be configured exactly the same way. And let me just write this down over here that the cations and anions are trading partners. And that is if the reaction is going to proceed. So if this reaction occurs, that must happen. For this reaction to occur, one of three things kind of must happen. So there's three criteria, A, B, or C must occur. So one of them, okay? Not all three of them, maybe all three do or several do, but at least one should occur. One of the products must be insoluble. And you write that as an S or a down arrow with the letter PPT, and this means it is a precipitate, which is basically a solid. Okay, so let me just explain that. So you take two clear liquids in a test tube, you mix them together in a third test tube, all of a sudden something shows up and you can start seeing stuff dropping to the bottom of the test tube. Okay, that is what you mean by a precipitate, and you represent that with S. S is totally fine. So what you're saying is that one of the products here, these are the two products, one of them must be pretty much insoluble, or can be very slightly soluble, but you're going to by and large write an S next to it. Or sometimes you'll see it written in reactions as a down arrow and the letter PPT, meaning precipitate. That's one possibility. The other possibility is you form a gas in the products. So one of the products is a gas, and you're going to see the letter G or an upward arrow. Means same diff. This refers to a gas. If you look over here, one of these could be a gas. Or the third possibility is you form a molecular compound. So one of the products is a molecular compound, and an example of that would be water. So now we're going to talk about some examples for double replacement reactions and how to balance them. And I'm going to treat potassium iodide, which is aqueous. I'm going to react it with lead 2 nitrate. So PbNO3, 2. I'm going to react potassium iodide with another aqueous solution. So if I gave you a bottle of each, they look just like water. Okay, that means they've dissolved perfectly. When you react them together, you end up with PbI2, lead iodide, which is a solid. So in this case, one condition has been met, so this reaction is definitely going to happen. Plus you form potassium nitrate. Okay, and this is aqueous. So the obvious question is, so how the heck do you know if this is a double replacement reaction? So you need to look carefully. Right here, this cation swap places with the lead. Okay, these guys swap places, and that is how you know you've got a double replacement reaction. Right here, you have a polyatomic ion, and on the right-hand side, you have a polyatomic ion. Remember, these are the reactants. Over here, these are the reactants, and these are the products. So you notice that the nitrate polyatomic ion, this is a polyatomic ion, shows up in both places, and it shows up unchanged in both places. And remember, a polyatomic ion has two elements on the card. So a polyatomic ion is basically an ion that has two separate elements combined together. And since these are showing up on the reactant side and the product side, we are not going to break them up. We're going to keep them together. We're going to practice balancing this: potassium, iodine, lead, and the nitrate ion. So this is very important. We are not breaking this up, and we're going to do the same thing on the right: potassium, iodine, lead, and nitrate. The reason we are not breaking these up is because they show up in both places, right here and right here, in the exact same form. Okay, now we're just going to start counting. 1 potassium, 1 iodine, 1 lead, and 2 nitrates. I hope you see that 2. That 2 is coming from here. We're just viewing this entire thing. We're keeping it. We're not messing. We're not breaking these up. We're not saying 1 nitrogen, 3 oxygens. We're keeping it all together. So you've got 2 of these here. Let's repeat the process on the right. Potassium 1, iodine 2, lead 1, and the nitrate ion. There's just 1 of these guys in here. So we write this over here. So now we're just going to balance them. So if you look at iodine, you need 2 of these over here. So what you're going to do is you're going to multiply this by 2. That'll give you 2. So you've got to take that multiplication factor. And please remember, you cannot in any way change the subscripts. So this goes as a coefficient right here. You've also got to remember that if there is no coefficient written here, like it's blank here, and blank here right now, that means there is a 1 in place in each of these places. So we've got the 2 right in front of the potassium iodide. The 2 applies to both the iodide and the potassium. So this also applies to the potassium. So we're going to cut that out and make it a 2. Why? Because there's a 2 here. So now we've got a situation where these are not balanced anymore. These are balanced, but the potassium is not balanced. So we're going to multiply that by 2. Take that 2 and write it right over here. Again, so that's going to be a coefficient. That 2, so this is 2 now. These are balanced. But let's deal with this nitrate. So this 2 also applies to the nitrate. This just became a 2 as well. These balance out now, and the leads balance out. Got a perfectly balanced equation on both sides. Potassium iodide plus lead 2 nitrate gives you lead iodide, lead 2 iodide plus potassium nitrate. This is a double replacement reaction, and I've just balanced this for you. And it's just good practice, folks, to be able to actually go through these reactions and write them down. So the second reaction we're going to do is going to be barium chloride reacting with potassium carbonate. Okay, and this reacts, so that I should have written those closer, but they're going to react. So barium chloride is aqueous. It looks like water. It dissolves well in water. Potassium carbonate is aqueous. This should be together. This is all together. And it gives us potassium chloride, which is aqueous, plus it gives us barium carbonate. Okay, and barium carbonate is a solid. This does not dissolve. These are the reactants. You got the products over here. So before I start balancing, I want to show you a couple of things. There is a carbonate here and a carbonate here. As a consequence, when you are balancing this reaction, you want to keep these together. You do not want to break them up. Okay, so this is yet again a polyatomic ion right here and right here. This is a card that has 2 elements. This also has 2 elements, therefore these are polyatomic ions. Keep in mind, barium is a metal, chlorine or the chloride ion is a nonmetal. That's an ionic compound. That is an ionic compound. Potassium chloride, again, ionic compound because there's a metal and a nonmetal, and barium carbonate is an ionic compound. The reason this reaction is going to proceed is because barium carbonate is forming a precipitate. It is not aqueous. Things to keep in mind. You cannot change the subscripts. And subscripts are these numbers written down below. So for example, that would be a subscript. That's what I mean by subscript. You can never change these numbers. You can change the coefficients. Remember, if there's nothing written, there is a 1. Barium, there's 1. Chlorine, there's 2. Potassium, there's 2. And the carbonate ion, as I mentioned earlier, we're not breaking it down. We're keeping it together. Same order on the right-hand side. Barium, chlorine, potassium, and the carbonate ion. Barium is 1. Chlorine is 1, or the chloride ion. Potassium is 1, and the carbonate ion is 1. So all these guys are 1. Over here, we've got a slight problem. We've got the chloride ion that is 2. And so we're going to need to fix that. We're going to multiply this by 2. That's going to give us 2. So this is balanced. The multiplication factor here for the chloride ion makes its way right in front of the potassium chloride, right there. Now this applies to the potassium as well, in addition to the chloride ions. So we're going to make this 2. And right here, we've got 2. So this is balanced as well. Bariums are balanced, and the carbonate ions are balanced. 1, 1, 2, 1. So really the ratio of this reaction is 1, 1. And here it would be 2 to 1. 1 mole of barium chloride reacts with 1 mole of and forms 2 moles of potassium chloride and 1 mole of barium carbonate. So that's a wrap on double replacement reactions. Hope you found that helpful. Bye.